Here we go with 2021 number 5, AB test, calculator inactive. This one is a lot of fun. Here we go. Consider the function y equals f of x, whose curve is given by this equation for y greater than, not equal to, 0. And then we're going to have to show that this is the derivative. So part A is basically implicit differentiation. This one's going to be pretty straightforward at first. So we're going to start, 2021, there we go, with 2y squared minus 6 equals y sine of x, and we're going to take the derivative with respect to x on this, and when we do, the derivative of this term is 4y dy dx minus 0, okay, so equals, product rule, so f prime g plus f g prime, and we're going to solve this thing for dy dx. So let's get all our dy dx terms on the same side. And as I'm looking at what they asked us to do, I was afraid I was about to take this in the wrong direction. And it doesn't matter if you do, actually. I'm just going to go for it. Let's bring this one, let's take this one over to this side. So 4y dy dx minus dy over dx sine x equals y cosine x. And we're going to factor out the dy dx. Skip a step or two here if you find it necessary. So obviously you know what you're aiming for. They've already told you what the derivative is. Now we're just going to work our way there. So dy over dx equals y cosine x over 4y minus sine x. Okay, my concern just about a minute ago was that I was going to move this to the other side and this to the left side, and in the process of doing so, I would end up with everything I have here but with opposite signs, which would be perfectly fine. We could divide the numerator and denominator by -1 or multiply them by -1 and get the same thing. It would just look different, take one extra step. But we have mission accomplished, part A, done. Okay, part B, write an equation for the line tangent to the curve. Stop. Write an equation for a tangent line, which means we're going to have y minus y1 equals m, x minus x1. Start identifying the parts. And the parts would be that x1 comma y1, you don't have to write all this, is 0 square root of 3. And we don't know the slope, but that slope is going to be the slope at that point, which would be dy dx at 0 comma square root of 3, which means that we're going to plug in 0 comma square root of 3 for all our x's and y's right here. So let's go ahead and do that. So square root of 3, cosine of 0, good thing we know the unit circle, 4 times the square root of 3, don't let that scare you, minus sine of 0. All right, we'll keep going with this. Cosine of 0 is 1, so that's square root of 3 times 1. Sine of 0 is 0, that gives us 4 square root of 3 minus 0. We can reduce that, it gives us 1/4. It's pretty straightforward. So y minus square root of 3 equals 1/4, and then x minus 0, that was pointless. So this is fine. I'm going to go a little bit further with it because it's a really easy fix. There we go. Not that this was broken. This one just looks a little cleaner. All right, now we get to the fun stuff. See if you weren't having fun already. I'm going to need a separate piece of paper for this one. This one's going to take some space. So here goes. For x is between 0 and pi, inclusive, and y greater than, but not equal to 0, find the coordinates of the point. Pause right there. When you're done with this, your answer will be a coordinate, and it is 1 point. It's only one coordinate. Where the line tangent to the curve is horizontal. Okay, again, to recap, you're looking for a coordinate, an x and a y, and the line tangent to the curve, okay, is horizontal. Now you might be thinking, oh, line tangent to the curve. I have a line tangent to the curve. Yeah, at a specific point, not at the point they're asking, okay? If we're going to have a horizontal tangent line, then the slope, let's just jump right in, the slope had better be equal to 0. So let's just set this slope that we found, but they also gave us, equal to 0. And doing so means the numerator had better equal 0. So we have a situation where y cosine x equals 0. Solve it. You're going to say, well, something times something gives me 0. So either y is equal to 0 or cosine of x equals 0. And we'll just go from there. Now, this is going to take us into some interesting territory where we have to have read very carefully. So first of all, x is stuck between 0 and pi, okay, and y is greater than but not equal to 0, so that one's out automatically. So now I have to figure out where cosine is equal to 0. Well, cosine equals 0 at pi over 2 and at 3 pi over 2 and at all kinds of other ones that it could go backwards, but let's just not get too carried away because, excuse me, because already we know that we are simply dealing with all the x's between 0 and pi, so that one's out. Found it. Okay, so final answer that we don't know is going to have an x value of pi over 2. So we're about to find the y value that goes with it. How are we going to find that y value? Okay, very beginning of the problem, they told us that the equation of the curve was this funny little thing right here. Right there. So don't make it harder than it is. You know your x, you're looking for your y. So plug in your x, find your y. So 2y squared minus 6 equals y sine of pi over 2. Okay, fair enough. The sine of pi over 2 is 1. So we have 2y squared minus 6 equals 1y. And then we'll just keep solving it. So 2y squared minus y, it's quadratic of course, so we'll move it all to one side, factor it out carefully. And let's see, 2y squared has no choice but to be 2y times y, unless we play with fractions, and we're not going to do that right now. 6 is going to be not 6 and 1, it's going to be 2 and 3, which will give me a 2 and a 3. I need a negative 4 and a positive 3. There we go. And that'll give me the negative 1 in the middle. So y equals negative 3 halves, and y also equals positive 2. All right, wait a minute now. We're only allowed to have one coordinate, so which one is it? I'm glad you asked. Y has to be greater than 0. It's good to know the conditions they give you. It's easy to be hunting for the question and ignore the conditions they give you, so be careful with that. So that y can't happen. Final answer, pi over 2, comma 2. All right, the next one's going to take another piece of paper. Probably could have squeezed this one onto half a piece of paper, but I didn't, and I really want to make sure I have room for this next one. So determine whether f has a relative minimum, relative maximum, or neither at the point found in part C. Justify your answer. Okay, so we're going to be dealing with what's called the second derivative test. And the second derivative test is this beautiful thing where we are going to grab a scrap piece of paper briefly, and you're just going to see the corner of it. And if I have a derivative that's equal to 0, and my second derivative is positive, then we have a situation where we're concave up, and this is truly going to be a minimum, relative minimum. Or if the first derivative is 0 and the second derivative is negative, then we have concave down, and so that point right there is going to be a relative max. I always like to draw that just to give you a visual. That's what's going on. Okay, so minimum, maximum, or neither. We're going to need the second derivative, and that's where this thing's really going to get out of hand. It's about to get really, really crazy. So let's start with part B with the first derivative, dy dx, equals y cosine x over 4y minus sine x. And it is about to get super sloppy because we're going to find the derivative. Now, we're going to find the second derivative, and we're going to find the value of that second derivative at, where's my work? Where's my work? I have so many papers floating around. At that point. Okay, pause for a second. I already know that this equals 0 at pi over 2 comma 2. That's what I was finding in the first place. So all this little scrap work we did here just a second ago where I was talking about the second derivative test, we've already met condition number 1. So as long as we can determine the sign of the second derivative, then we know minimum, maximum. That's what we're doing. So, all right, let's find the second derivative. Fun begins. D squared x over d squared y over dx squared. And that means derivative of the top times the bottom minus the top times the derivative of the bottom, all divided by the bottom squared. I said top and bottom rather than numerator and denominator. Don't tell my 8th grade math teacher. She'll be really upset with me because she got upset when we did that. All right. I won't tell you her name. You might look her up. So we got that part. That's easy. So here goes. Let's find the derivative of the numerator, which would be product rule. Whoa, product within our chain, and it's implicit. So there's that. Oh, this is going to be just the derivative of that. Y times the derivative of cosine, which would be negative sine, which makes that negative. Okay, derivative of the numerator times the denominator minus numerator times the derivative of the denominator. All right, always a good idea to pause here, especially if you're recording a video. Make sure you didn't say anything wrong, do anything wrong, or make a comment about your 8th grade math teacher. There we go. All right, we're good. All right, here's what's about to happen. Because my 8th grade math teacher was right. I should use mathematically appropriate language, not top and bottom. Let's use numerator and denominator. All right, here's what we're going to do. We're going to evaluate the second derivative at a specific coordinate. At what coordinate? Determine whether f has a relative maximum, minimum, or either at the point found in part C. So at that point. If you missed part C, take the answer you got and plug it in anyway. The work might be rough, but you're gonna keep plugging along with what you got. All right, so here goes. At pi over 2 comma 2, the derivative equaled 0. So basically that whole term is gone. So 0 cosine pi over 2, I don't care. Actually, that's 0 too. So we have 0 times 0. Man, that's all kinds of 0. Minus y sine of pi over 2. That takes care of this part. 4y minus sine of x minus y cosine of x. Debating on where to put my parentheses. And then 4 times the derivative at that point, which is 0, that's been established, minus cosine of pi over 2, which is also 0. Lucky us. All divided by 4y minus sine x, which would be this part, which is really this. So 4 times 2 minus sine of pi over 2. A lot of room for error here. I really don't care what it is. I just care about the sign of it, but I'm still going to have to keep working on it a little bit. So grabbing a green pen just because I want to. I'm going to mark out the zeros. That's going to make my life a little bit easier. This is 0 minus 0, actually. So this is 0, and we're multiplying by this. So even though this itself, 2 times cosine, cosine pi over 2, yep, that's also 0. So 0, they're gone. They're gone. All right, so we are left with negative 2 sine of pi over 2, which would be 1, times 8 minus 1 over 8 minus 1, all squared. So 49 in the denominator, negative 2 times 7 in the numerator, so that's negative 2 over 7. And I don't care that it's negative 2 over 7. I care that it's negative. There we go. All right, mission accomplished. We now know that the first derivative is equal to 0 at that point because that's the way it was engineered. That's what we did part C for. And we know the second derivative is negative. Therefore, we have a concave down situation, and we are dealing with a relative maximum. Justify your answer. Okay, the coordinate. Coordinate. I could have just listed the coordinate. Coordinate pi over 2 comma 2 is a relative of mine. It's my second cousin. No, I'm kidding. Relative max because I can spell that right. Okay, let's list our reasons. The first derivative, when evaluated at that point, is 0, and the second derivative, when evaluated at that point, is negative. Done. Done. Okay. Got that done in 15 minutes or less. All right. Let's grade this thing. Start back at the beginning. See what we're up against here. Number 5. Oh, 2 points here. Implicit differentiation and then the verification. So I'm debating on where exactly to underline. I believe this first line right here is worth something. And then just the process that kind of leads to this. So point here, point here. So verified first step, and then can you work it out to get to there? That's my understanding of that. So we cannot earn the second point without the first one, because if you don't have this, you're not going to get to that. All right, second part. You only get 1 point for this one, and that's it. I'm sure they'd give it to you for this as well. And actually, in the scoring guidelines, they have square root of 3 plus 1/4 x. Clearly the same thing. Okay, part C, worth 3 points. Here goes. We need to set the derivative equal to 0. We earned a point there. And then finding this was worth a point. And then finding this was worth a point. There we go. Got them. And part D is worth 3 points as well. So we need to, the scoring guideline says considers this. So did you think about that? Yes, we did. And then we got a point for finding the second derivative. So that negative 2/7. The second derivative at that coordinate, and then our answer with the justification, which is worded very well right here. We needed that in there.